Hello, this is Dr. Hanaa Assil, and today we're doing paper 2C, January 2022 of Edexcel IGCSE Chemistry. And the first question is, state the meaning of the term hydrocarbon. Remember that definitions are very important. Hydrocarbon is an organic compound containing carbon and hydrogen only, and you have to mention only because all organic compounds have carbon and hydrogen, but they may have carbon and hydrogen and oxygen or carbon and hydrogen and nitrogen. But if they have carbon and hydrogen only, that is when they're referred to as hydrocarbons. Now, give the reason why ethene is described as unsaturated. Remember, we said, what does unsaturated means? It means it has C double bond C, or it is an alkene. So we refer to alkenes as unsaturated because they have C double bond C. Alkanes are saturated because they have no C double bond C. Then he says ethene is bubbled through bromine water until there is no further color change. Which of these is the appearance of the solution formed? Remember that bromine water was the test for alkenes, and if I add bromine water to alkenes, what happens? It will change from reddish brown to colorless, or we say from orange to color. The next question is talking about ethanol, and he says ethanol is produced industrially by the reaction between ethene and steam. So he's talking about the reaction of ethene plus steam, which is water, to give ethanol. And he's asking what were the conditions. So you should remember that for this reaction, the temperature was 300 degrees Celsius, the pressure was 60 to 70 atm, and if he asks for catalyst, it is H3PO4 or phosphoric acid catalyst. Then he wants the molecular formula of ethanol. Again, remember that molecular formula means the total of the number of carbons and the number of hydrogens and the number of oxygens. So this is the molecular formula of ethanol, C2H6O. This question is about gases, and he gives me a pie chart that represents the percentages of gases in dry, unpolluted air. Dry means no water vapor. Unpolluted means there is no extra gas that is not supposed to be there. So which of these is gas Z? Which gas makes up most of air? It is, of course, nitrogen. Now, which of these is the approximate percentage of oxygen? You should remember that the percentage of oxygen in air is 21%. One of the trace gases is carbon dioxide. Identify two reactions that produce carbon dioxide by placing a tick in the boxes. Which of these reactions give carbon dioxide? The first choice is cracking. Remember, cracking is the breakdown of a long chain into shorter chains. It doesn't give carbon dioxide. Complete combustion would give carbon dioxide gas. Reaction between magnesium and hydrochloric acid? No, it gives hydrogen, not carbon dioxide. Rusting takes oxygen from the air to change iron into iron oxide. Thermal decomposition of copper carbonate? Yes, remember when we heat copper carbonate, it gives the oxide plus carbon dioxide gas. Name an environmental problem that is caused by the percentage of carbon dioxide increasing in the atmosphere. If we have too much carbon dioxide, this leads to global warming because we said carbon dioxide is a greenhouse gas. Name the trace gas with the highest percentage. The word trace gas means the gas in a very small amount. But he wants the one with the highest percentage, so the one that is not very much, but with a high percentage is argon, because argon makes up 0.9% of air. Rainwater is acidic because carbon dioxide dissolves in water to form carbonic acid. Acid rain is more acidic than rainwater because acidic pollutant gases also dissolve in water. Give the name of the acid. that forms when nitrogen dioxide dissolves in water. Remember that nitrogen dioxide gas is one of the gases that cause acid rain. When we dissolve nitrogen dioxide in water, it gives nitric acid. Name another gas that forms acid rain. Remember that the gases that form acid rain are oxides of nitrogen, like nitrogen dioxide, and sulfur dioxide. So that is the other gas that forms acid rain. The third question here says, this question is about solubility. The graph shows solubilities of copper chloride and sodium chloride at different temperatures. Determine the temperature at which copper 2 chloride and sodium chloride have the same solubility. Of course, when they have the same solubility, that is when they meet together at the same point. So you go down, he wants the temperature. If you read the temperature from there, it is 57 degrees Celsius. Remember, he says, show on the graph how you obtained your answer. So you have to draw that line or you will lose a mark. Then he says a saturated solution of copper chloride in 100 grams of water is cooled. That was the graph for saturation in 100 grams of water. Now, if he's changing from 40 to 10, that means that instead of having 31 grams dissolved in the 100 grams of water, he will have only 13 grams dissolved. So when we cool, remember that when we're doing crystallization, what do we say? We say heat to point of crystallization, and that means I have a saturated solution, and then cool to form crystals. So when we cool from 40 to 10, I will get 18 grams of crystals coming out of the solution, because at 10 degrees Celsius only 13 grams can dissolve. So remember that when we do crystallization, this is what we're doing, and the crystals that form are the ones that come out due to cooling. Then he says a student uses this method to determine the solubility of potassium chloride in water at room temperature. So he says record the mass of an empty evaporating basin, pour some saturated potassium chloride solution into the evaporating basin, record the mass of the evaporating dish or evaporating basin and saturated potassium chloride solution, heat the evaporating basin to remove all the water, record the mass of the evaporating basin and the dry potassium chloride. So basically, he's putting a saturated solution into the evaporating dish. So he has water with the maximum amount of potassium chloride that could dissolve in it. Then I heat it to remove all the water and I record the mass of the remaining solid. So this table shows the results, and he's saying calculate the mass of the dry potassium chloride obtained. Well, let's look at the table. He has a mass of the evaporating basin alone, and then he has evaporating basin and dry potassium chloride. So if I want the amount of potassium chloride, it is the difference between them. And then he wants the mass of water. Well, he has evaporating basin and saturated solution, and then he has evaporating basin and dry potassium chloride. So the difference between them would be the amount of water that was removed. Now calculate the solubility in 100 grams. From the information in these first two questions, I have 5.1 grams dissolved in 15 grams of water. He wants how much in 100, so I find that I will need to dissolve 34 grams in 100 grams of water. So just why the student's method is not suitable for determining solubility of hydrated copper sulfate. Remember, a hydrated crystal has water in it. So if I heat it to dryness, the hydrated copper sulfate itself would lose the water of crystallization. So what I would be calculating is not the mass of hydrated that was dissolved in the water. Question 4 says, this question is about the reactions of group 1. He says a teacher adds a piece of sodium to some water. The equation for this reaction is this. The water contains universal indicator. The sodium floats, so he already tells me that the sodium floats. The universal indicator changes color because alkaline solution is formed, sodium hydroxide. Now give two other observations. Please remember that when he says give two other observations, you do not repeat the one that he gave you. So I don't say sodium floats again, but I can say sodium darts, melts, strong fizzing. I could also say that the bubbles of gas may catch fire. Okay. What would be the final color of the universal indicator? Of course, if I have sodium hydroxide, then the universal indicator paper will turn to blue, or we could refer to it as purple. The diagram represents an atom of lithium and an atom of sodium. Give a reason why lithium and sodium have similar reactions with water. If he's asking why any two atoms have the same reactions or they have same chemical properties, it is because they have the same number of electrons in outer shell. So we said any two atoms in the same group have the same number of electrons in outer shell, so they will have the same chemical properties. So lithium and sodium, for example, are in group 1, then they both have 1 electron in the outer shell. Explain why lithium is less reactive than sodium. Remember, reactivity in metals has to do with how easily they lose the outermost electron. So why did we say lithium is less reactive? Well, because lithium has less shells, so the outermost electron is nearer to the nucleus, so there is stronger attraction forces between the outermost electron and the positive nucleus, so it is not easily lost. While in sodium, I have more shells, the electron that is to be lost is further away from the nucleus, so there is less attraction forces between that electron and the positive nucleus. The teacher adds 0.15 grams of lithium to an excess of water and collects the hydrogen gas produced, and he gives you the equation. And he says the teacher collects 254 centimeter cubed of hydrogen gas. Show by calculation that 1 mole has a volume of about 24,000 centimeter cubed. This is what we usually say, that the volume of 1 mole is 24 decimeter cubed or 24 centimeter cubed. So here he is bringing it the other way around. He's asking you to calculate that it is really 1 mole has a volume of 24 decimeter cubed or 24,000 centimeter cubed. Okay. What does he give me? He gives me information about lithium, 0.15 grams of lithium. Remember that we said in any calculation, if he gives me information, usually the first thing you need to do is get the number of moles of that. So number of moles of lithium would be the mass over the molecular mass, 0.15 divided by the molecular mass of lithium, which is the big number from the periodic table. Please remember, the mass number is the big number in the periodic table. So that comes out to this number of moles. Then he's asking me about what? About hydrogen. The next step is usually in all of these calculations, the next step would be look at the equation and relate what you got to what he's asking about. You got the number of moles of lithium. What is that with respect to the number of moles of hydrogen? Well, from the equation, hydrogen is half the lithium, so the number of moles of hydrogen will be half the number of moles of lithium. Then he wants the volume. The volume is 254, so the 0.0107 moles have a volume of 254. So if I have 1 mole, what would be the volume of that? So you're dividing the total volume by the number of moles. This gives you something that is approximately 24,000 centimeter cubed. So this is correct. Okay, question 5 says hydrogen peroxide solution decomposes to give water and oxygen gas. three different solids are catalysts for the decomposition of hydrogen peroxide. A solution is given hydrogen peroxide, a student is given hydrogen peroxide solution and a sample of each of the solid catalysts. The student has a timer, a measuring cylinder, a balance, and the apparatus shown. Remember, if he gives you specific apparatus, you have to use each of that. So what does he want? He has three solids and he wants to know which one of these is the better catalyst. So how do we do that? Well, describe a method the student could use to find which of the three solids is the most effective catalyst. We're going to use this apparatus. And you need to explain using all the choices that he gave you. So usually when we have three catalysts and I'm trying to find out which one is the better one, I put a certain amount of the solution into the conical flask connected to a gas syringe using a measuring cylinder, because he mentioned measuring cylinder and you have to tell him what you're using it for. Weigh 1 gram of the first solid using a balance. He mentioned that. Put into the flask, close the bung. Remember, the bung is that thing we close the mouth of the flask with, and start the timer, because he said we are going to use a timer. Now, what are we measuring? We're going to measure the volume of gas collected in 1 minute in the gas syringe. This is one of the methods that you could use. You could either tell him measure the volume of gas collected in 1 minute, or measure the time taken to collect a certain volume, for example. This one is easier. Repeat using what? But you have to tell him what you're using the same in each experiment. We're going to use the same volume of H2O2, and we're going to use the same mass of each solid. The one that gives more gas in 1 minute, that's the same time, is the better catalyst. Then he says the diagram shows the reaction profile for the decomposition of hydrogen peroxide without a catalyst. Label the diagram to show the activation energy and the enthalpy change for this reaction. Where is the activation energy and where is delta H? You have to remember, activation energy is the energy from the reactants to the top. The delta H is from the reactants to products. That is where delta H is. And notice the direction of the arrows. On the diagram, draw a curve to show the reaction profile for the same reaction when a catalyst is used. Remember, when we use a catalyst, we said this speeds up a reaction. Why does it speed up the reaction? Because it provides an alternative pathway with lower activation energy. So that new graph has a lower activation energy, and it's going also from reactants to products. This question is about the electrolysis of copper 2 sulfate. The diagram shows the apparatus used. A student records the total increase in mass of the negative electrode every minute for 8 minutes. So what he's doing is he's doing electrolysis of copper 2 sulfate. Remember, when we do electrolysis of copper 2 sulfate, it is the copper ions that deposit on the negative electrode. So the copper ions are going to gain electrons and cover the negative electrode. So he's measuring the mass of the negative electrode from the beginning till after 8 minutes. Plot the student's results and draw a curve of best fit. So we're going to plot the points using small x's. Please do not just write a dot. You either use small x's or a dot with a small circle around it. You cannot use just dots. And then you need to join this with a smooth curve of best fit. Explain the shape of the graph. This was the shape of the graph. Now, what is happening in the graph? The mass is increasing and then it stops increasing. So at the beginning, it's increasing because the copper ions gain electrons, become copper, and it deposits on the negative electrode. So the mass increases, he says, explain, since the copper metal deposits on the electrode. And then at the end, the graph becomes horizontal and stops increasing when no more copper ions are in solution, when we have finished all the copper ions in solution and no more copper is being deposited on the negative electrode. The product at the positive electrode is oxygen. The student repeats the electrolysis using different apparatus. Describe how the student should collect a sample of pure oxygen at the positive electrode. Remember, we said when we do electrolysis and we want to collect the gases, how do we collect the gases? So we fill the test tube with copper sulfate solution and invert it over the positive electrode. The hydrogen gas will go up, displace the solution, and collect in the test tube. Then he says, give an ionic half equation for the formation of oxygen. Remember, how does oxygen form? It's from the reaction of the OH minus, that is from the water in the solution. So the OH minus loses electrons, becomes oxygen and water, and this is the balanced equation. The wire used to connect the power supply to the electrodes is made of copper. He has the diagram of a metal. Metals that are malleable can also be stretched to form long, thin wires. So just why metals can be stretched. We said, remember, that metals are malleable and ductile. Why are they malleable and ductile? Because the layers of positive ions can slide over each other when heated or hammered. Explain why metals conduct electricity. Remember, when we're explaining this, they have free moving delocalized electrons. Please don't mention ions. It is due to the movement of the delocalized electrons that are free to move. The next question is about esters, and he says ester A reacts with water to form ethanoic acid and ethanol. The displayed formula of the reactants and products are shown. So here he's starting with the ester and he's doing what we call hydrolysis of the ester. When we break up the ester by reaction with water, this is called hydrolysis. Remember that when we were forming the ester from the ethanoic acid and the ethanol, that was called condensation. This type of polymer reaction is called condensation reaction. So here we're breaking up the ester. This is hydrolysis of the ester. And he's saying the molar enthalpy change for the reaction is 0. First of all, draw a ring around the functional group in the ester. Where is the functional group of the ester? This part, the C double bond O, single bond O, that is the functional group that identifies an ester. Remember that the acid has this same thing, but it has an OH, not an O and then bonded to C's. Give the name of this ester. How do we name the ester? We said we start from the name of the alcohol from which it was made. It was made from which alcohol? From ethanol. So the name would be ethyl something. The acid was ethanoic acid. So the ester is ethyl ethanoate. Describe a chemical test other than using an indicator. You don't mention indicator. That means you don't mention litmus paper. You don't mention universal indicator. He's saying a chemical test to show that the reaction contains ethanoic acid. What was the chemical test for acid without using indicator? Remember that in the tests, we used acid to test for carbonates. So when we need to test for acids, I can use carbonate. So I tell him add a specific carbonate. Don't say add carbonate. Add something carbonate. Sodium carbonate. Bubbles of gas are formed that turn lime water milky. That means that what I added was an acid. Explain why the molar enthalpy change for the reaction between ester A and water is 0. Remember, when I tell you that the delta H is 0, what does that mean? If we have a reaction, what we're doing is we're breaking the bonds in the reactant. So the ester and the water, we're breaking bonds. And breaking of bonds needs to take in energy. It's an endothermic process. Now, when bonds form in the products, they give out energy. So that is an exothermic reaction. Now, if he's telling me that the delta H is 0, that means the energy needed to break the bonds. Now, which bonds are we breaking? We're breaking CO bond because we're breaking the ester into two, and we're breaking the water, the OH bond, and then we're forming the same kind of bond. We're forming again CO bond and OH bond. So actually, there is one CO and one OH broken and formed. So the same bonds broken or the same bonds formed. So the energy needed to break the bonds in the reactants is the same as that given off when bonds are formed in the product. So the delta H, we said, is the reactants minus the products. Well, they're both the same, so the delta H is 0. Okay? A mixture of ester A and water is left in a sealed container until the reaction mixture reaches dynamic equilibrium. Remember that this reaction was reversible. Now, what is dynamic equilibrium? You have to remember the definition. The rate of forward reaction equals the rate of backward reaction, and concentration of reactants and products remain constant. Don't say remain the same. They're not equal. The reactants is not equal to products. But the reactants are a certain number that does not change, and the products are a certain amount that do not change. So the concentration of reactants and products remain constant. These are the conditions for dynamic equilibrium. Explain why adding a catalyst does not change the position of equilibrium. Remember that we said a catalyst speeds up a reaction. So if we're talking about rate, the rate increases. But if we're talking about a reversible reaction with position of equilibrium, the catalyst does not change the position of equilibrium because it speeds up both forward and backward reactions to the same extent, or it speeds them up equally. So it doesn't favor forward or backward reactions. The ethanoic acid produced in the reaction is completely neutralized by this amount of barium hydroxide. He gives me the equation and he says calculate the number of moles of ethanoic acid. Again, he gives me information about what? He gives me the volume and concentration of barium hydroxide. I use that, number one, I use that to get what? Number of moles. So the number of moles of barium hydroxide, this is a solution. So concentration times volume. Please remember that the volume has to be in decimeter cubed. So if he says the volume is 22.75, you have to divide that by 1,000 before you put it into the equation. And he gives me the concentration. How do I know which one is the concentration? The one that has units mole per decimeter cubed. So the 0.15 mole per decimeter cubed is the concentration times the volume in decimeter cubed, that is after dividing by 1,000. This gives me the number of moles of barium hydroxide. And then we said, what would be the next step? Look at the equation, relate what he gives you to what he's asking about. So I have the number of moles of barium hydroxide. He's asking about what? The ethanoic acid. Where is the ethanoic acid? That's that first one, CH3COOH. So what is the relationship? The number of moles of ethanoic acid should be twice that of barium hydroxide. So that is the number of moles of ethanoic acid that he wants. Then he says the structures of two organic compounds are shown. These compounds react together to form a polymer. Draw the polymer. Again, how do we draw polymers? We said from the acid you remove the OH, and from the alcohol you remove the H and you join. So this would be the final diagram for the polymer. Okay, that was the end of the paper. I hope this was useful to you and thank you for listening.